I welcome you all. In this video, I'm going to solve the one more problem based on design of knuckle joint. This problem was asked in May 2011. Now let us go through the problem statement. Design a knuckle joint for a tie rod of a circular section to sustain a maximum pull of 70 kilonewton. So this maximum kilonewton in this problem statement is nothing but the force applied on the rods of knuckle joint. And instead of simply rod, here it is mentioned that it is a tie rod. Okay, so we know that the knuckle joint is used in the tie rod to connect two tie rods in the roof truss. Okay, so this is the name of application where the knuckle joint is used. Okay, and it is subjected to a force of 70 kilonewton. The ultimate strength of the material of the rod against tearing is 420 Newton per mm square. Now this is very important. The ultimate strength is given for the material of rod. So ultimate strength is given for the rod against tearing, that means against tension, and its value is 420 Newton per mm square. So here this word is important, against tearing. Okay, so ultimate strength in tearing, that means ultimate strength in tension, and it is for rod material. Now next is ultimate tensile and ultimate shearing strength of the pin material. Now this next property, that is ultimate tensile strength and ultimate shear strength for the pin material, is given, and its values are 510 Newton per mm square and 396 Newton per mm square respectively. Then in this numerical, we have to determine the tie rod section, that is the diameter of rod, that is capital D, and pin section, that is diameter of pin, that is small d. Now in this problem, we have to take the factor of safety equal to 6. Okay, so factor of safety Fs we have to take as a 6. So with this statement of numerical, we will write the given data first. Now let us write the given data. So the maximum pull acting on the rod of knuckle joint is 70 kilonewton. That means force P is given 70 kilonewton. So convert it into Newton by multiplying by 10⁻³ . So now next is ultimate strength of the material of rod is given in against tearing, that means against tension. So this is nothing but the ultimate strength in tension for a rod. It is here it is written that for rod SUT is equal to 420 Newton per mm square. Now next is ultimate tensile and ultimate shear strength of the pin material is 510 and 396 Newton per mm square. So for pin material we have SUT of 510 Newton per mm square and SSU as 396 Newton per mm square. So this is ultimate strength in tension for pin material, and this is ultimate shear strength for pin material. So its values are 510 and 396 Newton per mm square. Now next is factor of safety is given, it is 6. Okay, so that is written here, and we have to determine the tie rod section, that is the diameter of rod. So under the heading of determine, we have to write first point the diameter of tie rod, that is capital D, and second we have to determine the pin section. So we have to write the diameter of pin, that is small d. Okay, so we have to determine the rod section, that means diameter of rod capital D, and we have to determine the pin section, that is nothing but the diameter of pin, that is small d. Okay, so these two parameters we have to determine. So let us solve this problem. Now before actual starting of solution, we have to find out the permissible stresses. So here we have to write the heading, calculate the permissible stresses. So before deciding which permissible stresses we should calculate, for that purpose just go through the parameter that we have to determine. So first parameter is the diameter of rod or diameter of tie rod, that is capital D. And this capital D can be calculated from the step number 1 of design procedure of knuckle joint. And this is the equation to find out diameter of this rod. In this equation, the P is nothing but the applied force in Newton, and sigma T is nothing but the permissible tensile stress. So that means in order to find out the diameter of rod, we required only the permissible tensile stress. Now the second parameter that we have to determine is the diameter of pin, that is small d. And this diameter of pin small d can be calculated from the step number 4 of design procedure of knuckle joint. And in this step number 4, we can calculate the diameter of pin based on shear stress tau and based on bending stress sigma b. So this is the equation to find out the diameter of pin based on shear stress. And this small d is nothing but the diameter of pin. This p is nothing but the external applied load in Newton, and tau is nothing but a permissible shear stress. So in order to find out the diameter of pin, first permissible stress we required is permissible shear stress. Now the second equation is, this is the second equation to find out the diameter of pin. Okay, so where small d is the again diameter of pin, p is the external applied force in Newton, a is nothing but the thickness of fork end, b is the thickness of eye end, and sigma b is the permissible bending stress. So in order to find out the diameter of pin based on this bending stress, we require to find out this sigma b, that is permissible bending stress. So in short, to find out the diameter of rod, we have to find out the permissible tensile stress for rod material, and in order to find out the diameter of pin, we have to find out permissible shear stress for pin material and permissible bending stress for pin material. Okay, so these three permissible stresses we have to calculate for this numerical. Now, as we discussed, first of all we have to find out the permissible tensile stress for a rod material. So I have written here for rod. So for rod, to find out the permissible tensile stress, this is the equation: sigma t is equal to SUT upon Fs. Okay, so let us refer the value of SUT for rod. So value of SUT for rod, it is given 420 Newton per mm square, and Fs is 6. So let us put the value of this SUT 420 and Fs 6 for this rod. And if you calculate this value of this permissible tensile stress for rod or material, its value will be 70 Newton per mm square or megapascal. Okay, you can write the unit megapascal also. Okay, so this is the value of the permissible tensile stress for rod material. Now similarly, let us calculate the permissible stresses for this pin material. And the first permissible stress we required is permissible shear stress, that we have to put in this equation to find out the diameter of pin. So this permissible shear stress is given by SSU upon Fs, where SSU is nothing but the ultimate shear strength and Fs is the factor of safety. So this SSU value we have to refer for pin material, and its value is 396 Newton per mm square for this pin. So let us put the value of this SSU. It is 396, and Fs is 6 for both rod and pin. So let us put the value of Fs 6. If you calculate this, you will get the answer of this permissible shear stress for pin as 66 Newton per mm square or 66 megapascal. Now the second permissible stress that we require to calculate is permissible bending stress for this pin, so that we can get the diameter of pin based on bending stress. Permissible bending stress, that is sigma b, and which is equal to permissible tensile stress, as we discussed. So always the permissible bending stress and permissible tensile stress are equal. Okay, and it is given by SUT upon Fs. So for pin, the value of SUT is 510 Newton per mm square and Fs is 6. So now let us put this value of SUT. So SUT value for pin is 510 and Fs is 6. So if you calculate this value, you can get the answer of as 85 Newton per mm square. Okay, so by referring this step number 4, where we have to calculate the diameter of pin, we have calculated first permissible shear stress, so that we can calculate the diameter of pin based on shear stress, and second permissible stress that we have calculated is permissible bending stress, so that we can calculate the diameter of pin small d based on bending stress. Okay, so these are the two permissible stresses that are required to calculate the diameter of pin. Now in the solution, after calculating the permissible stresses, we have to find out these two parameters. So write down first point as calculate the diameter of tie rod, that is capital D. And by referring the first step of design procedure of knuckle joint, we can write this equation to find out the diameter of rod of knuckle joint. So now let us write down this equation. So this equation is capital D is equal to under root 4p upon pi into sigma t. Okay, so this is the equation we have to refer from the step number 1 of design of knuckle joint, and we have to use here to find out the diameter of a rod. Now we have already calculated the permissible tensile stress of this rod material. It is 70 Newton per mm square. So we have to put this value of sigma t as 70 Newton per mm square here. Value of P, it is given 70 into 10 raised to 3 Newton, and we can calculate this diameter of rod from this equation. So I have put here the value of P 70 into 10 raised to 3 Newton, which is given in the numerical statement. Then I have put here value of sigma t as 70, which we have calculated in the solution initially under the heading calculate the permissible stresses, and this is the value of sigma t for this rod. It is 70 Newton per mm square. So this is the value of permissible tensile stress sigma t. Now let us calculate this value of diameter of rod, that is capital D. Now if you calculate this capital D, you will get the answer 35.68 mm. And from manufacturing consideration we have to round off this. So let us take the value of capital D as 37 mm by adding 2 mm into this calculated answer. So this is the first answer that we have to determine, that is calculate the diameter of rod, and this is the diameter of rod of knuckle joint. Now the second point that we have to determine in this numerical is the diameter of pin small d. But from the step number 4 we know that the diameter of pin small d can be determined on the basis of shear stress, that is tau, and on the basis of bending stress, that is permissible bending stress sigma b. So now let us find out first based on shear stress. To find out the diameter of pin based on shear stress, we can use this equation from the design procedure, and that is from the step number 4. So let us write this equation to find out the diameter of pin. So this equation is d is equal to under root twice p upon pi into tau. So now the value of this p, it is already given in the problem. It is 70 into 10 raised to 3 Newton. The value of tau we have calculated under the heading of permissible stresses for pin, and the permissible shear stress tau is 66 Newton per mm square. So we have to put here tau as a 66, p as a 70 into 10 raised to 3, and we can calculate by putting these two values. We can calculate the diameter of pin small d based on shear stress. Now I have put here the value of p as a 70 into 10 raised to 3 Newton, value of tau as a permissible shear stress, which is calculated as a 66 Newton per mm square here, and if you calculate this, you can get the answer as 25.98 mm. Okay, so this is the answer of diameter of pin based on shear stress. Now let us calculate the diameter of pin based on bending stress. Now to find out the diameter of pin based on bending stress, that is sigma b, we can refer the equation number 2 of step number 4 of design procedure of knuckle joint, and this second equation is small d is equal to cube root of 16 into p a by 3 plus b by 4 upon pi into sigma b. So let us write this equation here. So small d is equal to, where small d is the diameter of pin, cube root 16p, p is the external applied force, into bracket a by 3, where this a is nothing but the thickness of fork end, plus b upon 4, where this b is nothing but the thickness of eye end, upon pi into sigma b. So pi into sigma b, where this sigma b is the permissible bending stress that we have calculated under the heading of calculate the permissible stresses for pin. So this is the permissible bending stress which we have taken equal to permissible tensile stress, and its value is 85 Newton per mm square. So by putting the value of p, a, b and sigma b, we can calculate this diameter of pin based on bending stress. But here the value of p and sigma b we know. We have calculated the value of permissible bending stress sigma b. P is given, but a and b is not given in the problem. So first of all we have to calculate this a and b, and then we have to put here the value, its value, to get the value of diameter of pin. So this is the equation to calculate thickness of fork end small a, which is equal to 0.75 times of diameter of rod, that is capital D, and this is the equation to find out the thickness of eye end, and its equation is small b is equal to 1.25 into capital D, that is diameter of rod. We have calculated the diameter of rod as 37, so let us put the value of capital D here. So 0.75 into 37, so if you calculate this, you will get the answer of as 27.75. So let us take the value of this small a as 28 mm. Okay, let us take this value of small a as 28 mm, and again here put the value of capital D, again same value 37. If you calculate this, you can get the answer 46.25. so you can take this answer as 47 mm. Okay, so this is the answer for this small b. Now let us put this value of a and b here. Sigma b already we have calculated. Here it is 85 sigma b, and p is 70 into 10 raised to 3 Newton. So by putting this all the values, you can calculate this small d. So now I have put here the value of p in this equation as 70 into 10 raised to 3, value of a as 28, value of b as 47, and value of sigma b as 85 Newton per mm square. And if you calculate this answer, you can get the value of this small d as 44.55 mm. Okay, so generally we select the diameter of pin, maximum value of diameter of pin, which is calculated based on shear stress and bending stress. But here, as we don't have to follow the further steps, so it is not necessary to write the statement that select the maximum diameter from these two values. Okay, if you have to solve all the steps, then it is obviously it is necessary to write the statement and select the maximum value from these two values. Okay, so diameter of pin based on shear stress is 25.98 and diameter of pin based on bending stress is 44.55 mm. Okay, so this is the solution to this problem.